Hi, I'm Balasubramanya, freelance consultant in smart grids and smart meters. I'm going to talk to you about the communication technology in smart grids and smart meters. Communication is the key distinguishing capability of smart metering over conventional electricity meters. Reliability, stability, and sustainability of the proven technology behind the communication network is the key to the success of smart metering mass rollout program. Different communication technologies are available today depending upon the system integration, sustainability, suitability, and application oriented systems are the main crux of the communication system as a whole. In fact, smart grid intersects the electrical grid with automation, communication, and IT system that can monitor power flow from point of generation to the point of consumption, even down to the appliance level, and control the power flow or curtail the load to match the generation in real time domain. Increased visibility, predictability, and even control of both generation and demand allow utilities to better manage variability, integrate intermittent renewable generation, and also reduce cost of peak power. Smart grid needs secure communication. In fact, there are seven domains identified by the NIST. This is an architecture we call this consisting of the generation, transmission, distribution, customer as one particular four domains, and the market operation and service provider as the three-pronged approach. That means seven communication system as such will entail the smart grid to make it more reliable and also sustained one in the integrity of the communication system. In fact, there are different approaches for the communication system. The HART communication protocol is one, which is a hybrid analog digital industrial automation protocol. So its most notable advantage is that it can communicate over the legacy 4-20 milliamps analog instrumentation current loops, sharing the pair of wires used by the analog only host systems. The layers of communications, in fact, the communication network of a smart grid has three-level hierarchical structure consisting of a home area network HAN, neighborhood area network NAN, and wide area network NAN. The wireless communication, due to its advantages, is identified as a potential candidate for smart grid communication, especially in HAM and NAN. However, wireless transmission is inherently unreliable, whereas communication reliability is one of the fundamental requirements of smart grid applications. A two-layer communication model based on the IEEE reference grid is considered for NAN, and a method based on transmission redundancy is proposed to prove the reliability of wireless communication in NAN, while the communication delay requirement of the smart grid is considered as a restriction. Smart meter communication. In fact, there are three things here. One is the smart meter, the other is the router, and the other is the collector. Smart meter as a traffic generator designed with a global IPv6 address receives demand response data from the collector. The router takes the responsibility of relaying packets from both smart meters and collectors. It determines the next hop for the packet to reach the final destination. Collector serves as interconnection between the NAN and a WAN in the smart grid aggregation. All meter reading information, collector node collects all meter reading data and sends acknowledgement back to the corresponding meters. In fact, the smart meter basic architecture consists of a bidirectional system from smart meters to the applications are LAN, collectors, and WAN. So when we talk of the smart meter, it is a solution provider. In fact, the solution smart meter is not a meter, it is a solution provider. The database or database structure, how often will meter be read, how will the data be proposed and stored, is a main index of the communication system. Before we proceed further for the discussion, let us understand how smart meter works. Smart meters measure energy consumption, production, and provide information, power quality, or electricity meter can be measured. The data is transferred via powerline communication system, mobile network, and radio waves to the smart metering system at the energy utility point. The data is collected in the head-end system and further processed in the meter data management system. The data is forwarded into further IT systems like customer information system, distribution management system, etc. So the metering data is used for billing and customer services. The end communication receives bills based on the actual energy consumption. So they are able to follow their individual consumption pattern through a portal or in-home display system. The real-time data is available to the utility customer service management system, and also the smart metering solution can be provided to interface the home energy management system. There is an apprehension that smart meter measure electricity usage and communicate this information back to the supplier using short bursts of radio waves or radio frequency, which may be dangerous to the health care of a person. In fact, Health Canada has conducted that the exposure of RF energy from smart meter does not pose a public health risk. There are other things to be considered in the smart grid communication system. One is the standards and interoperability, which is one of the major things in the system integration. The main challenge is the HAM, home area network. The band, building area network, uses short-range wireless standards such as Zigbee, Thread, Wi-Fi, Bluetooth to connect home appliances to smart meters. So it may also use the PLC, power line carrier, the wireline technology. The NAN, neighborhood area network, uses either a star network topology such as the cellular M2M, GPRS, 3G, LTE, MTC, NB-IoT, LPWAN to connect each meter directly to base substation, and also to the cloud or a mesh network topology such as the PLC or IEEE 802.15, and 4G to aggregate all smart meter to nodal points so that a DAP, the data aggregation point, is obtained. I'm going to talk about only two things here. One is, the smart meter integration challenge. Number one, the integration of smart meter into electricity grid involves implementation of variety of techniques of software depending on the features that the situation demands. The second is communication between various items at any point of time in the infrastructure should be done on open communication protocol, as no energy utility would like to get locked to the hands of any one vendor service provider. I think these are all the main things which I thought I should discuss with you with regards to smart meters and smart grid communication system. In fact, more information I will give you in the next video. Thank you.